This mole looks like something has exploded out of its face, but that wet pink star is not an accident. It is the animal's main way of seeing the world. The star-nosed mole lives in dark, muddy tunnels and swampy ground, where eyes are almost useless. So instead of looking around, it sweeps the world with 22 fleshy rays surrounding its nostrils, touching the ground so fast that its nose works less like a normal nose and more like a high-speed touch eye. At first, it is hard to even understand what you are looking at. The face is small, the body is dark and velvety, with huge digging feet and a short, compact shape built for pushing through wet soil. Then the head turns, and the nose seems to unfold into a tiny pink sea anemone. 11 rays on one side, 11 rays on the other. Each one is soft, mobile, and constantly moving. They are not feelers in the casual sense. They are a scanning device. They are the reason this animal can hunt in blackness, choose prey in fractions of a second, and even sniff underwater by blowing bubbles and sucking them back in. The strangest part is that the star does not make the mole clumsy. It makes the mole fast. Imagine crawling through a tunnel where there is no useful light, where the walls are damp, where roots, stones, insect larvae, worms, and bits of debris all press against your face. For most animals, that would be chaos. For the star-nosed mole, it is information. Every tiny touch becomes a point on a map. The star is only about the size of a fingertip, but it is packed with around 25,000 specialized touch structures called Eimer's organs. Under magnification, the surface is not smooth. It is covered in thousands of little raised domes. Each dome is wired with sensory cells and nerve endings that respond to pressure, texture, and movement. So when the mole presses its star against mud, it is not just feeling that something is there. It is reading shape, edge, hardness, and surface detail at extremely high speed. That is why calling it a nose is almost misleading. Yes, the nostrils are there, right in the middle. The mole can smell. But the star itself is mainly a touch organ. It is skin turned into a sensor array. A fingertip has touch receptors spread across it. This animal has taken that idea and built it into a crown of living probes around its mouth. And because the rays point outward in a circle, the mole can sample a wide area directly in front of its face without stopping. The star is always tapping. It flicks against the tunnel floor, the walls, the water, the prey, then back again. In real time, that looks like a blur. Slow it down, and the animal's strategy becomes obvious. The outer rays are scouts. They sweep across the nearby world and catch the first hint of something interesting. If a ray touches a possible food item, the mole instantly shifts the most sensitive part of the star onto that spot. That special region is a pair of central lower rays, often described like a touch version of the fovea in our eyes. In human vision, the fovea is where detail is sharpest. We glance around with our eyes, then point the fovea at whatever matters. The star-nosed mole does the same thing with touch. It scans broadly, then snaps the high-resolution part of its nose onto the target. That motion is so quick it looks almost mechanical, but it is a living animal solving a problem. In a tunnel, food is scattered in tiny packets, a small worm, a larva, a bit of insect. A mole has a high metabolism and cannot waste time inspecting every pebble as if it were dinner. The star lets it sort the world at the speed of survival. This is where the animal becomes almost unbelievable. Star-nosed moles can identify and eat very small prey in as little as about 120 milliseconds. That is faster than a human blink. In some experiments, the decision about whether something was edible took only about 8 milliseconds. 8 milliseconds is not a thoughtful pause. It is a nervous system built to say yes or no almost instantly. Touch, decide, bite, swallow, move on. The mouth is positioned just behind the star, so once the mole has confirmed prey, there is almost no wasted motion. The sensor and the feeding machine are packed into the same tiny space. The star finds the food, centers it, and the teeth take over. That speed makes sense when you picture the mole's world from inside the tunnel. There is no wide-open hunt, no chase across a field, no dramatic pounce from a branch. The mole is pushing through a crowded, wet, three-dimensional maze. Its prey is often small, hidden, and mixed with non-food objects. A slower animal might need larger prey to make each search worth the effort. The star-nosed mole can afford to take tiny meals because it can process them so quickly. It has turned the dirt into a buffet of split-second decisions. And the brain behind this nose is just as strange as the star itself. Sensory information from the rays is heavily represented in the mole's brain. The layout of the star is mapped in the nervous system, so the animal has a kind of internal touch picture of the surface in front of it. The most important rays get extra processing space, just as important body parts get oversized maps in many animal brains. This is the key to the whole mystery. The star is not just weird skin. It is part of a complete sensory system, from soft pink rays to microscopic touch organs to thick bundles of nerve fibers to enlarged brain maps. Evolution did not just add decoration to a mole's face. It built an interface for darkness. And darkness is only half the story, because this mole also lives in wet places. Star-nosed moles are found in marshes, wet meadows, stream edges, and saturated soils. They dig tunnels like other moles, but they are also strong swimmers. They can move through shallow water and forage underwater, which creates a problem for a mammal. Smell is normally an air-based sense. On land, odor molecules ride into the nose with inhaled air. Underwater, you cannot simply breathe in water to smell it. But the star-nosed mole uses a trick that looks impossible the first time you see it. It blows small bubbles from its nostrils onto objects or scent trails underwater, then pulls those same bubbles back into its nose. The bubble touches the thing in the water. Odor molecules enter the air inside the bubble. Then the mole re-inhales it, sampling scent while still submerged. It is not breathing water. It is carrying a tiny pocket of air to the smell and bringing that air back. The star helps make the whole performance even more alien. A mole underwater, face covered in pink rays, releasing and re-inhaling silver bubbles, is one of those real animal behaviors that looks invented. But it fits the animal perfectly. In water, the star can still touch, the nose can still scan. And with bubbles, the nostrils can still gather chemical clues. The same face that reads mud can also investigate submerged prey, trails, and objects. That means the star-nosed mole is not simply a tunnel animal with a bizarre nose. It is a wetland specialist with a sensory toolkit for places where vision fails twice, first in darkness and then in murky water. The more you look at the star, the less monstrous it becomes. Each ray is short, soft, and delicate, but together they create a ring of rapid contact. They do not grab prey like fingers. They do not sting. They do not taste the world like tongues. They press, tap, and sample. The animal is constantly making tiny contacts, building a picture from touch the way we build a picture from light. If you put yourself inside that sensory world, the tunnel stops being empty blackness. The wall has texture. The mud has patterns. A worm is not invisible. It is a curved, soft signal against the background. A beetle larva is a different shape, a different resistance, a different surface. A pebble is rejected almost immediately. The mole does not need to see a scene. It needs to know what is directly in front of its mouth right now. That is why the star is on the nose, not on the paws or tail. It sits at the leading edge of the animal. Before the teeth arrive, before the body squeezes forward, before the mole commits to a direction, the star has already touched the future. There is a simple reason this animal feels so unreal to us. Humans are visual creatures. We expect important information to come from eyes, and we expect a face to be arranged around looking. The star-nosed mole is arranged around contact. Its eyes are tiny. Its fur sheds water. Its front feet are built like shovels. Its tail can store fat for hard seasons. Every part of the body points toward a life spent pushing through cold mud, tight tunnels, and shallow water. In that world, a normal, cute mammal face would not be the best design. A star of sensors is better. The opening shock is that the mole appears to have a flower, a wound, or a creature attached to its snout. The payoff is that the star is neither decoration nor deformity. It is one of the most sensitive touch organs known in any mammal, compressed into a patch of skin smaller than what we would use to press a button. It lets the mole turn darkness into detail. It lets it turn a muddy tunnel into a readable surface. It lets it make feeding decisions at a speed that seems too fast for an animal that spends its life underground. And when the tunnel fills with water, it can even carry smell in bubbles, pushing air out into the underwater world and pulling information back in. So the next time that pink star looks impossible, flip the image around. Do not think of it as a nose that became strange. Think of it as an eye made of touch, placed exactly where a blind hunter in the mud would need it most. The star-nosed mole does not live in a world of darkness. It lives in a world that lights up when it touches it.